Hello students, welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. So we want to know if PS is parallel, right? That's what these two lines mean, is parallel to QR. Well, we can see we have a triangle here. We have triangle QNR. And I know the Triangle Proportionality Theorem says if these are parallel, then PS will cut both of these sides into segments that are proportional. So the ratio of the segments created by P of one side will be equal to the ratio of the lengths that make up the other side. The converse of the proportionality theorem says, of the triangle proportionality theorem, says that if those segments that make up the side lengths are proportional, then we can draw these arrows. So we want to know, is 90 to 50, is the ratio of 90 to 50 equal to 72 to 40? Let's see. There are two ways that we can do this. One is by reducing the fractions. So the zeros cancel out here and I have 9/5. Or you can think of this as dividing by 10 on the top and bottom. Dividing by 10 and like canceling the zeros are the same thing, because when I divide 90 by 10, I just take away a zero. But anywho, on this side, I can divide by 8 on the top and bottom, and I get 9/5. Yay, those are the same. So, another way you could do this is by cross-multiplying. 90 times 40 is 3,600, and 72 times 50 is also 3,600. So you can cross-multiply, and that will also show you, yes, these are proportional. So because these ratios are equal, PS is parallel to QR. Yes. Yes, indeed, we can draw these arrows in. They are parallel. Woohoo! Nice little review of what we did in the last video. Now, let's see what we have for today. Today we're going to finish up section 8.4. We're going to learn about some more proportionality theorems, other places where we can find proportions, either in a triangle or with parallel lines and transversals. So, our learning target is that you know what the Three Parallel Lines Theorem and the Triangle Angle Bisector Theorem say. So two theorems that we need to know and understand. That's our learning target, is to know and understand these theorems. Our success criteria is to be able to use these theorems to solve problems. So you might notice a pattern. That's kind of recently, that has been our learning target and success criteria, is what are these theorems? How can I use them? So, without further ado, we're going to again review ratios. Ratio of A to B can be written as a fraction, and a proportion is when I set two ratios or two of those fractions equal to each other. All right. Now, here is one of our two theorems that we are aiming to learn in this video. The Three Parallel Lines Theorem. If three parallel lines intersect two transversals, then they divide the transversals proportionally. Now, I know that there are so many lengths floating around this picture. How on earth am I supposed to remember what make up the ratios? Is it UV? Is it WY? Is it XV? Is it YZ? What numbers, what sides do I use here? So here's how I remember. We want UW, and let me color code. We want UW the ratio of UW to WY to be equal to the ratio of VX to XZ. So notice we have three parallel lines that intersect two transversals. So the transversals are the lines that are not necessarily parallel. They could be parallel, but they are the lines that are other than the other three, right? We have three parallel lines. The other two lines are the ones that are being split up into proportions. So when we're dealing with these problems, don't pay attention to the three parallel lines. Pay attention to the lengths created by these three parallel lines intersecting the transversals. These red segments are the ones that we care about. Okay, I think seeing an example of this is going to help. So let's move on to an example. In the diagram, angle 1, angle 2, and angle 3 are all congruent. Angle 1, angle 2, and angle 3 are all congruent. Why would we need to know that? Why would they say that? Well, do you see any arrows here saying that these lines are parallel? No, we aren't told that these lines are parallel. I don't know if Main Street, 2nd Street, and South Main Street, I have no idea if they're parallel. But the fact that they told us angle 1, angle 2, and angle 3 are congruent, what type of angles are angle 1, angle 2, and angle 3? These are corresponding angles because they're in the same relative position, right, to this intersection. Top left, top left, top left. So because these are all corresponding angles and they are all congruent, we remember from section 3.3, and if you don't remember, I'll put a link in the description. When corresponding angles are congruent, the lines are parallel. So what this first sentence tells us is that we have parallel lines. That's why they would say that. And it's actually very important that they said that, because if these lines weren't parallel, well, how would we find the distance? We can't use the three parallel lines theorem unless we have parallel lines. So it's a good thing that they said angle 1, angle 2, and angle 3 are all congruent. All right, now we know that GF is 120 yards, DE is 150 yards, and CD is 300 yards. Find the distance HF between Main Street and South Main Street. So we want this whole segment right here. We want distance HF. Well, HF, I can just take FG and GH and add them together. I can do that. But what is GH? I don't know what GH is. But what I do know is that because I have three parallel lines that are intersecting two transversals, they divide the transversals proportionally. So I know that the ratio of lengths in one transversal, 120 to x, is equal to the lengths in the other transversal. So 150 to 300. Now, I have seen them, so forget, this is correct, but I've seen people compare the wrong side lengths before. I've seen them say 120 to 150 is equal to x over 300. We're not comparing the lengths like across from each other. We're comparing the lengths in the same transversal. So you don't want to compare anything other than, here is one transversal. 120 is in that transversal, and x is in that transversal. Okay. All right. So here is our proportion. Let's cross multiply. 150 times x is 150x, and 120 times 300 is 36,000. Divide by 150 on both sides, and we get x is equal to 240. Are we done? Are we finished? Well, let's see. X is 240 yards. But this was GH. This is the length of GH. Did we want the length of GH? No, we wanted the length of HF. We wanted the total length between Main Street and South Main Street. So, we need to take HF is equal to HG plus GF, these two pieces, and we have HG is X, X is 240, 240 yards plus 120 yards, which is 360 yards. So HF is 360 yards between Main Street and South Main Street. Awesome. Cool. Let's check and see if we were correct. Distance between Main Street and South Main Street is 360 yards. Cool. So, method 1, use the Three Parallel Lines Theorem to set up a proportion. HG is 240. Add it to 120, get 360. That's exactly what we did. Now, there is another method you can use to solve this problem. I think that it's a little more confusing, so I'm not going to talk about it in this video, but if you are like, this was confusing, might as well try the other one, you can read it in the notes posted in our Google Classroom or posted on my website. You can read them, or you could pause the video now and read it and see if you like this way better. All right. Next, so we finished talking about the Three Parallel Lines Theorem. That was the first theorem in our learning target and success criteria. The second theorem was none other than the Triangle Angle Bisector Theorem. So, this theorem says, if a ray bisects an angle of a triangle, so if we have this red angle bisector here, then it divides the opposite side, so that's side AB. It divides it into segments, so segment AD and segment DB. It divides it into segments whose lengths are proportional to the lengths of the other two sides. So the ratio of these sides, or these segments, excuse me, the segments created by the intersection of this angle bisector here, those segments should be equal to the ratio of the other side. The other two sides, AC and CB. Now, notice how we kept AD as one of the segments. The side that connects with AD goes on top. The side that connects with DB goes on the bottom. So we have to stay consistent. Again, we can't be flipping our fractions or we're going to get answers that are a little bit wrong. So, the angle bisector cuts the third side into two pieces, AD and DB. We make a ratio out of those, and we make a ratio out of the other two sides. Those ratios are equal. Alrighty, let's see an example of this. Example 4. In the diagram, angle QPR is congruent to angle RPS. It's important that they say that because that tells us that PR is an angle bisector. If they didn't say that these two angles are congruent, PR would just be some random segment, but it's an angle bisector. And that is important because PR is an angle bisector. We can set up a proportion. I know that the side that the angle bisector intersects creates two segments. So the ratio of QR to SR needs to be equal to the other two sides. So QR is on top, so QP will be on top, and SR is on the bottom, so PS will be on the bottom. Let me erase this so our diagram's a little cleaner. Now let me substitute the lengths in here. QP is 7. PS is 13. Equals SR is X over, what is QR? I know this entire thing is 15, and this chunk is X, but what is QR? Well, what if we knew what X was? What if X was 10? Oh, well then QR would be 5. QR would be 15 minus whatever SR is. So QR is actually 15 minus X. It's the entire side minus this piece of the side. So we have 15 minus X. Now, how do I solve this? Proportion. Or it is a proportion. I can solve it using cross multiplication. So 7x equals 13 times 15 minus x. Oops, minus. That doesn't look like a minus sign. There we go. All right, now I can distribute 7x equals, what is 13 times 15? 195 minus 13x. Let's add 13x to both sides. 7 plus 13 is 20. The 20x equals 195. Divide by 20 on both sides. And we get that x equals 9.75. A decimal. That's weird. Usually we don't have decimals. How can I check and make sure that this decimal is correct? How can I make sure that I haven't done something wrong? Well, if x is 9.75, that means that SR is 9.75, and it means that QR is 15 minus 9.75, or 5.25. So let's plug these numbers into our proportion and make sure that we're correct. QR is 5.25 over 9.75. That needs to be equal to 7 over 13. So let's cross multiply and see. 7 times 9.75 is 68.25, and that should be equal to 13 times 5.25, which is 68.25. So it might be a little weird that we got a decimal, but we checked. Decimal was correct. So another way that we can check is, oh wait, we wanted to find the length of RS. Okay, we did. RS is X and X is 9.5 or 9.75. Okay, just making sure that we finished the problem before we go on to check our answer. So 15 minus X over X equals 7/13. That's what we had. Cross multiply and we get that X is 9.75, or RS is 9.75 units. Units because they didn't tell us whether we were in feet or inches or centimeters or something like that. But yay, we were correct. Okay, that is all I have for you today. Now would be a fantastic time to rate yourself and your understanding of the learning target and the success criteria. So, do you know what the what the Three Parallel Lines Theorem says and what the Triangle Angle Bisector Theorem says? Do you know if this, then what? If what, then this? Do you know? Do you know what the theorems say? And can you use them to solve problems? Did the examples we did make sense? If so, be sure to help your classmates, help your friends, help your family. If you're a little iffy, you're like not 100% sure, that's okay. Try the homework, see if that can help solidify your understanding. And if you are totally lost, that's okay. We have all been there. I want to stress, it is okay to feel bad about what we're learning, to not understand. That's okay. We all start there, and we all have times where we don't understand what's going on. So if you don't understand what's going on, that's okay, but don't give up. Ask a teacher, ask a friend, comment on this YouTube video for help. Here are some practice problems you can do to practice the skills that you have learned in this video. So we have some like example 4 and some like example 3. Alrighty. Our launch today comes from Oprah Winfrey, and she says, "Education is the key to unlocking the world. It is a passport to freedom." I love this, and honestly, I would like to hear Oprah talk more about it instead of my interpretation, but I'll give you my interpretation since I'm here and Oprah's not. Education is the key to unlocking the world. This is similar to what we talked about in the last launch, in the launch of the last video, I think, of like knowledge is power. The more you know, the more you unlock the world, the more you're able to do, the more you're able to understand the world around you and how it works and how people work and how they interact and how the world interacts. A passport to freedom. I want to think freedom of, I mean, we talked about this in the last video, freedom of financial worry. Like if you have a good education, you can get a good job and you don't have to worry about money. You don't have to worry about, like, if you get a good education, you can get a job where, like, they need you. They will not fire you. Like teachers, they need teachers. Like, it is very unlikely that I will lose my job just because, like, they laid off teachers or something like that. Unless, like, budgets get cut or I do something really bad, right? Then I could lose my job. But typically, they're always going to need teachers. So I have a good shot of, like, having a job forever. Whereas if you get, you know, I don't know, some other job, it could be easy for them to fire you and replace you. So freedom from, worrying about having a job, freedom from worrying about money, freedom from worrying about the unknown. Am I the only one that worries about the unknown, worries about things that I don't know the answer to? And not just math problems. I mean, you know, like what's going to happen in this situation or something like that. I feel like the more I know, the more I can understand, the less the unknown worries me. So, I'd be curious to see, how do you interpret this launch? How do you interpret what Oprah's saying here? What does it mean to unlock the world? What does a passport to freedom look like? And how could education help you do that? Unlock the world or get a passport to freedom. So think about that for yourself and see, what could education do for you if you let it? So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.